Hey there, STEM Chemistry. This is Miss Relark, and this is podcast 5.2a, where we're going to talk about the special types of reactions, which include acid-base reactions, combustion reactions, and redox reactions. Okay, so an acid-base reaction is one that always involves an acid and a base. Those two, of course, are reacting because it's an acid-base reaction. The nice thing about these, the way you can tell if you're not sure if it's an acid and a base reacting, is you look at your products, and they will always produce a water, H2O, and a salt. Now, a salt meaning an ionic compound, so it's going to have a metal first, or ions in it. All right, so chemical formulas for acids, we know these all begin with hydrogen, and chemical formulas for bases will typically begin or end with hydroxide, but not always. There are some that don't have hydroxide in them that are bases, and that's why I said if you're unsure if it's an acid and a base, look at the product. Okay, acid-base reactions are a specific type of double replacement reaction, and examples of these would be, now I don't have my pen with me, so I'm writing with my mouse, so if it looks really funny, I'm sorry. All right, H2SO4 will combine together to form, guess what? The hydrogen attaches itself to the OH, which gives us HOH or H2O, right? I'm just going to, and I think I'm only going to do one of these because this is taking me a while. All right, and then plus the K is going to attach itself to the SO4. Well, remember, ionic compound. K has a positive 1 charge, and SO4 has a negative 2 charge. SO4, oh, see, I really wish I had my pen with me. Okay, so those cross down, and we end up with K, oh, this is horrible, I know, 2 SO4. And that's a 4, I promise. Okay, and then try the HCl and the NaOH. It'll take me forever to do it, and it just wouldn't do us justice. But on the other side, you should have HCl plus NaOH, arrow, yields H2O plus NaCl. All right, note, acids and bases are opposites, so one will always be used to neutralize or cancel out the pH on the other. All right, in a combustion reaction, an element or a compound has to react with oxygen to produce energy in the form of heat and light. So commonly these involve hydrocarbons, not always, but most of the time. And combustion of hydrocarbons will always produce carbon dioxide and water. The combustion will continue to go until the oxygen supply is used up or the fuel, the hydrocarbon, runs out. All right, examples of these. You have C2H5OH, which is ethanol. And I've tried this before. It haven't been successful with the flame writing. If I can get it to work, I'll show you. If I can't, we will keep moving on. But for this one, we would have C2H5OH plus O2 gives us CO2 plus, it's real easy, H2O. Yeah, horrible. All right. Methane. Light your teacher on fire. You guys try this all the time when you go to light your Bunsen burners and you don't get them lit immediately, and all of a sudden that big huge flame comes up, right? Yep. CH4 plus O2 gives us CO2 plus H2O. Funny, they all end the same thing. All right, and then the methanol, CH3OH, or the whoosh bottle, and I will try to get that set up for you this week as well. You would end up producing, again, CO2 and H2O. Yay, easy. All right, so redox reactions. We call them redox because we don't like to say oxidation reduction. It's just too long. So we put them together, redox. Or the first part is for the reduction, and OX is for the oxidation, of course. All right, so a redox reaction is one that involves the gain and loss of electrons. It can also deal with the addition of oxygen to a compound. So oxidation is the loss of electrons from a substance or the addition of oxygen to a compound. Now, on your paper you have a picture of a lion, and I'm sure somewhere it says Leo says Gur. All right, and then the other one is Ulrich. All right, so Leo says Gur is just an acronym. It's a way to remember which one goes with which. So loss of electrons, oxidation. Gain of electrons, reduction. All right, and then the oil rig as well. You can use that for oxidation reduction. So both processes will occur simultaneously. You can't have one happen without the other one happening. All right, a single replacement, a combination or synthesis, decomposition, and combustion reactions are all going to be redox reactions. There will be a transfer of electrons that happens in that process. A double replacement and an acid-base reaction are not redox reactions, and no electrons are exchanged, and the ions are just trading partners. All right, so classify the change of the underlying elements as oxidation, reduction, or neither. So on this one, copper is going from a 0 charge to a positive 2 charge. Is it gaining electrons or is it losing electrons? Remember, Leo says Ger, right? So if it is so it is losing electrons because it becomes a positive charge. Losing electrons, oxidation. So this would be an oxidation. All right, Al with a positive 3 charge gains 3 electrons and becomes 0. So this is going to be a reduction. CH4 and CO2. So the question is, what kind of charge does this have? Well, you have to look at what it's attached to. There's 4 hydrogens, and each hydrogen has a positive 1 charge, which gives us a total of a positive 4 charge. Well, to cancel it out, it has to be a negative 4 charge. Okay with that? Hope so. All right, there's 2 oxygens. Each oxygen has a negative 2 charge, which means that this has an overall of a negative 4 charge. Well, this carbon has to have a positive 4 charge to cancel that out. It went from a negative 4 to a positive 4. Okay, so if it went from negative to positive, it had to lose electrons, which means that it is an oxidation. And also, we added oxygen to it, oxidation. All right, NaOH plus HCl, NaCl plus H2O. Excuse me. All right, so what we're doing is determining our oxidation states. Okay, so go through and see if you can do the rest, 4 through 8. We'll check these when you get to class, next class. All right, and we'll see how we do. And I think that's it. All right, I will see you in class.